A startling disclosure made by the James Webb Space Telescope uncovered what had all the earmarks of being city lights in space found 7 trillion miles from Earth. This momentous finding has sparked interest in the possibility of extraterrestrial life. The telescope zeroed in on Proxima Centauri b, the nearest exoplanet to Earth, uncovering strange, brilliant lights radiating from it. What could be the cause of these city lights on Proxima Centauri b? Could this show the presence of life beyond our planet? Join us as we delve into how the James Webb Space Telescope identified these unprecedented items in space. For years, researchers and people at large have anticipated and explored the possibility of life beyond our solar system. Any evidence seen to back up the space dream has been greeted wholeheartedly. Recently, mainstream scientists were shocked when strong evidence of living things existing in space was seen by the James Webb Space Telescope. While exploring outer space and relaying data back to Earth, the James Webb Space Telescope saw bizarre city lights sparkling from the exoplanet Proxima Centauri b. These lights, as their name suggested, appear to illuminate a far-off city. The possibility of an alien city existing on the star has left researchers in awe. They are perplexed since this could be the presence they've all been waiting for. If this ends up being true, as many believe it might, it means that intelligent living things are building civilizations unknown to what humans know in outer space, and we are just beginning to find it. Looking into the city lights found 7 trillion miles from Earth, NASA engineers can't help but wonder how long these lights have been shining in space, waiting for humanity to develop the technology necessary to detect them. David Kipping, a space expert from Columbia University, describes the Proxima b exoplanet, where the city lights were found, as intriguing. He said so because this star system closest to us has fluctuating warming patterns that aren't like those of other planets. The typical rocky planets are known to absorb sunlight and emit infrared radiation, but not for this exoplanet, as its infrared nature is very different from that of its host star Proxima Centauri. This hints at a significant observation by the James Webb Space Telescope, JWST, which is capable of detecting infrared frequencies. The distinct heat signature of Proxima b will play a key role in uncovering the planet's atmospheric mysteries. Thanks to the latest technology in infrared imaging, researchers plan to use the JWST to uncover the secrets of its atmosphere. They also expect to use the telescope to assess the possibilities of life on this exoplanet. The James Webb Space Telescope has infrared sensitivity that can investigate what happens on Proxima Centauri b's nighttime side, capturing even the faintest beams of light in the vast darkness. This is typically a challenge for space telescopes, but not for the JWST, which can detect even the smallest light emissions from space. It is the perfect tool to check if the rumors about city lights on Proxima's night side are true. Any artificial lighting in the universe can be detected by the telescope as long as it falls within a frequency band 1,000 times smaller than starlight. Proxima b has an interesting connection between its celestial elements and surface features. The daytime side of the exoplanet contains a vast number of solar panels that harness the radiant energy from the star. Its spectral edge also reflects incoming light beams. At the same time, when Proxima b completes its orbit around its host star, Proxima Centauri, it experiences day and night periods like those on Earth. During the day, it encounters high solar heat, while at night it cools down. The planet is known to have fluctuating temperatures determined by its composition. For example, if there's no atmosphere on Proxima b, the difference between its day and night periods will be very fast and extreme. Without the moderating effect of atmospheric gases, the temperature on the day side will be very hot and the night side will plunge into cold darkness. The degree of temperature variation is a major subject for astronomers to unravel, providing a deeper understanding of Proxima's atmospheric composition. With the JWST's unparalleled infrared imaging capabilities, it will enable efficient analysis of the planet's thermal emissions to provide valuable information about its atmospheric properties. Curiously, the orbit of the James Webb Space Telescope around Earth aligns with Proxima b's orbital period, allowing for thorough observations of its day and night periods within just 11.2 Earth days. Since Proxima b does indeed have an atmosphere, the next step will be to assess its atmospheric chemistry to determine if it can support life. Key signs of life include the presence of gases like oxygen, water vapor, and methane. If these elements can be found on the planet, it would suggest habitable conditions. The process of effectively determining this requires researchers to be careful as they capture and analyze light beams traveling through the planet's atmosphere. This is a challenging task to undertake. Even with the JWST's extraordinary abilities for describing planetary atmospheres, the James Webb Space Telescope, while powerful, does not have absolute capabilities and can only peer at a few of the closest exoplanets to Earth to conduct intensive atmospheric examinations. Astronomers are now looking towards ground-based observatories like the Extremely Large Telescope, ELT, which is planned to begin operations in 2028. The ELT is set to probe the atmospheric structure of faraway exoplanets and will produce data that offers in-depth insights into their habitability. NASA researchers and the public eagerly await the development of future space telescopes like these. Until then, the James Webb Space Telescope remains an essential tool in our quest to uncover the secrets of distant exoplanets. Despite its current limitations, the JWST has the potential to provide profound insights that could revolutionize our understanding of exoplanetary exploration. Researchers have set a goal for future space telescopes to reduce the amount of bright light coming from a planet's host star, allowing astronomers to better see the light reflected from the planet itself. They plan to do this by using masks or large external satellites shaped like an umbrella. Similar to using your hand to block out sunlight in order to see an object more clearly, reducing the harsh brilliance from a host star will enable future telescopes to focus on faint reflections of light from a distant exoplanet, allowing for a more striking investigation of its atmosphere and the possibility of supporting life. However, this comes with its own challenges as researchers will need to differentiate between gases produced by life and those from geological processes such as volcanic activity. Astronomers are not giving up on understanding the characteristics of exoplanets to better spot signs of life beneath the surface and distinguish them from false positives. The Webb telescope represents a glimpse of scientific advancements in exoplanet research, offering a preview of the astonishing discoveries we have yet to make. As we extend our understanding and exploration of the universe further, we are better positioned to comprehend the complex workings of the universe and our various roles within it. After searching all the planets in space, researchers have yet to find one that harbors life. Despite decades of scanning through space for signs of life, the mission continues. Are we alone in the universe? For centuries, people have wondered whether they are the only ones in existence. This age-old longing still persists today. Even now, researchers have the James Webb Space Telescope in space, attempting to spot alien civilizations hidden among us while studying various planetary bodies for signs of life at the same time. A popular story has emerged recently, suggesting that some aliens could really be out there in the stars, just waiting for humanity to find them. To address this question, two American astronomers, Jill Tarter and Thomas Pearson, started a project called the Search for Extraterrestrial Intelligence, SETI. Founded in 1984, the SETI Institute is a non-profit venture that aims to sift through astronomical transmissions to detect radio signals from space. The reason for focusing on radio signals is their ability to travel long distances without getting scattered or absorbed, unlike other types of radiation. Due to this property, radio transmissions are more likely to be detected by the 42 radio telescopes that make up the Allen Telescope Array located in the Cascade Mountains of California. Although the SETI Institute has diligently monitored signals of these radio transmissions generated by alien life, no such signals have been detected for over 30 years. Jill Tarter remains hopeful about the chances of success, expressing a desire to enable Earthlings everywhere to become active participants in the ultimate quest for extraterrestrial intelligence. All of this continued until recent reports from NASA indicated that the James Webb Space Telescope spotted city lights from a planet near Earth. The JWST is the giant card played by humanity to gain a better grasp of the cosmic mysteries in space. Launched in December 2021, it is known as the best infrared imaging telescope ever made by humanity. Equipped with the most advanced optical technology available today, the James Webb Space Telescope can look past the veil of cosmic dust to uncover the secrets of the universe. Its primary mission is to explore the universe in search of the first galaxies and stars that were formed billions of years ago. The telescope is designed with some of the most sophisticated optical technology in the world today. Inspired by James E. Webb, a visionary NASA administrator who was a key advocate for space exploration and the Apollo moon landing programs, the James Webb Space Telescope is built with a unique array of instruments, all working together to provide unparalleled views of the universe. This includes a near-infrared camera, a near-infrared spectrograph, a mid-infrared instrument, and a fine guidance sensor that allows it to maintain its precise position in space. The giant mirror of the James Webb Space Telescope, consisting of 18 hexagonal segments, has been carefully crafted to capture faint light from the earliest galaxies in the universe. It is designed to operate at extremely low temperatures, allowing it to detect weak heat signals emitted by distant objects. Since its launch, the James Webb Space Telescope has been able to capture extraordinary images and send back insightful data, uncovering fascinating new findings about the universe. While it has primarily focused on studying exoplanets, galaxies, and distant stars, this groundbreaking discovery of city lights in space has led researchers to reevaluate the potential of extraterrestrial life. The discovery of city lights on Proxima Centauri b has stunned scientists, and the research continues to develop. The James Webb Space Telescope's capacity for exploring the farthest reaches of space has allowed it to bring humanity closer to finding answers to the ultimate question. Are we alone in the universe? As researchers continue to study the discovery of these unusual city lights on Proxima Centauri b, questions abound about the next steps in unraveling the mysteries of extraterrestrial life. One of the most pressing questions is whether these lights are indeed artificial, as the patterns and intensity of the emissions suggest that they may not be naturally occurring phenomena. Some scientists hypothesize that these lights could be an indication of technologically advanced civilizations or perhaps even bioluminescent organisms creating artificial light in some form. The possibility of artificial lighting originating from such a distant exoplanet challenges existing assumptions about the limits of life in the universe. In addition to the potential for artificial lights, there is the possibility that what appears to be city light may be a natural phenomenon that has yet to be understood. Some astronomers speculate that the patterns could be the result of unique atmospheric processes, perhaps linked to Proxima Centauri b's volatile climate or interaction with its host star. The magnetic fields, radiation belts, and complex atmospheric chemistry of the exoplanet could create visual effects that appear to be city lights to the telescope sensors. Though this remains a point of contention among experts until further data is gathered, both hypotheses will be carefully studied. A key aspect of future research will focus on how the light emission changes over time and whether it follows any predictable patterns. The James Webb Space Telescope's ability to observe the planet consistently over time will allow researchers to gather crucial information about whether these light emissions are stable or whether they fluctuate in a manner consistent with patterns of artificial activity, such as those generated by electrical power grids or other forms of human-made infrastructure. Long-term observation is critical, as it could reveal additional clues that lead to a breakthrough understanding of the phenomenon. Moreover, as technology advances, scientists will likely develop even more sophisticated tools and methods for analyzing exoplanets. The next generation of space telescopes and ground-based observatories, such as the aforementioned Extremely Large Telescope (ELT) and upcoming space missions, will provide additional capabilities to detect signals and gather data that the JWST alone cannot achieve. Together, these instruments will form a collaborative network of space exploration that could ultimately confirm the presence of life, or at the very least, lead to more profound discoveries about distant worlds and their potential for habitability. As the search for life beyond Earth progresses, the possibility of detecting intelligent life through the study of city lights on distant exoplanets has opened an entirely new avenue for scientific inquiry. While humanity has yet to definitively prove the existence of extraterrestrial life, each discovery, whether it is a faint signal, strange light emission, or unexplainable phenomenon, brings us one step closer to answering this age-old question. The implications for science, philosophy, and society are profound. Discovering that we are not alone in the universe could forever change how we view ourselves and our place in the cosmos. Furthermore, if such discoveries lead to the identification of advanced alien civilizations, it would likely initiate a new chapter in human history. The possibilities of exchanging knowledge, culture, and even technology could revolutionize many aspects of life on Earth. However, it is also important to consider the ethical implications and potential risks associated with contact with extraterrestrial beings. Scientists and policymakers will need to carefully consider how humanity should respond to such a monumental discovery. The ongoing work of the James Webb Space Telescope represents just the beginning of an exciting era of exploration. The telescope's ability to peer deeper into space than ever before allows it to capture the faintest signals and the most distant objects, bringing us closer to understanding the true nature of the universe. In the coming years, as more discoveries are made and more data is collected, humanity will continue to search the stars for evidence of life, and the answers to some of the most profound questions in science and philosophy may finally be within our reach. As we look to the future, the idea that we might one day communicate with or encounter intelligent life forms beyond Earth is no longer relegated to the realm of science fiction. With every new technological advancement, we inch closer to a reality where the lights shining from far-off exoplanets are not just a curiosity, but a sign of something much greater, a message from another civilization that might be out there waiting for us to discover them. The James Webb Space Telescope has made this potential more real than ever, offering a glimpse of a universe filled with possibilities we are only beginning to comprehend.